Hello everyone. Today I'll show the solutions to problems 5 and 6 of round 191 of the Prairie Math League. For problem number 5, we have a diagram where we have two right triangles AED and BFC, which are constructed inside rectangle ABCD so that F is on DE. We're given that AE is equal to 21, so this is 21. DE is equal to 72, and BF is equal to 45. And we wish to find the length of AB. Now, the first thing we can do is find this length because we know Pythagoras, right? So, applying Pythagoras on AED, we find that AD is equal to 75. But so is BC because this is a rectangle, and therefore we can apply Pythagoras again to complete triangle BFC, and this gives us that FC is equal to 60. So now we've gotten this length, which is not what we wanted. We want this length. So what we're going to do is we're going to try to find a length that we can construct. In this case, we're going to extend it, this altitude over here, over to AD, so that this length is basically equal to this thing. Now, this thing we can find with the well-known height formula, but in this formula, basically, we take advantage of the fact that this times this divided by 2 is equal to the area, but so is this times this divided by 2. So therefore, this height here is equal to this times this divided by this. So if we call this, let's say, G, then FG is equal to BF times FC divided by BC by some area chasing. And this gets us that FG is equal to 36, just to do the arithmetic. Now this length is quite a bit hard to find, but notice that in much the same way we found FG, we can find the length of this altitude over here. By the way, these are altitudes, so these are 90 degrees. We can find the length of this one over here, and so since, okay, let's call this H and I. Notice that EID is similar to FHD. So now we just need to figure out this length and this length, because the ratio of this to this is equal to the ratio of this length to this length. Now to do that, we're going to take advantage of a few more right triangle properties. So if we have a right triangle over here, there's a very useful configuration, specifically that this triangle is actually similar to this triangle, but also similar to this triangle. So we have three similar triangles, and we can use that to find the lengths of basically anything we want. So if we're given this, this, and this, we can also find the height, this thing, and this thing. Now we're going to take advantage of that to find ID. So notice that ID is equal to ED times ED over AD, because we're noting that EID is similar to AED. So doing some arithmetic, this gets us that ID is equal to 1,728 over 25. Now, we can also find IE in much the same way we found FG, and IE turns out to be 504 over 25. Finally, we want to find HD. Now, HD can't be found directly here, but notice that HGCD is a rectangle, so we just need to find GC. And we can apply the same trick we used to find ID here in this triangle to find GC in this triangle. And again, GC is equal to FC times FC over BC. And this gets us that, HD is equal to, in this case, 48. Because this is 48. Now we're ready to compute HF, and this is equal to IE times HD over ID. And if we divide out all these fractions, it turns out that we get a much nicer looking value of 14. So HF is equal to 14, and as we saw earlier, FG is equal to 36. Therefore, their sum is 50, which is option choice E. And now we move on to an easier problem, although still geometry. So we have a cubical length with edge, we have a cubical cake with edge length 2 inches. So the cake looks like this, and we make vertical cuts that look like this and this. So if you can see this diagram, our cuts are here and here, and we wish to find the sum of the area of B and the volume that B is on top of. So this volume of cake here. Now, notice that we can simplify this to just an expression in terms of the area of B. Specifically, if we let, I don't have a better expression. If we let B in square brackets be the area of B, then the volume is actually just, the volume is just 2 times B, because this is the area, the volume that B is on top of when the cake, the rest of the cake, so like the other dimension has length 2. So it's 2 times the area of B, which is the volume. So our total is basically 3 times the area of B. And if this was an AMC or something and you're trying to save time, look at all the option choices here. We can see that none of these are like multiples of 3, because like, although you can divide by 3, you're going to get more fractions. But this thing over here is literally a multiple of 3, because this is 24. So if you didn't have time, then you would guess option choice A and move on. And as we'll see later, this is the right answer. But anyways, we wish to find the area of B, and the answer is 3 times the area of B. Now, the area of B can be found as follows. So suppose we draw this line here. Notice that this is an isosceles triangle with this 2, 2, 1, 1. And by Pythagoras, this is square root of 5, and this is square root of 5, this is 2. And let's just transfer over to this diagram here because it's easier to see. So we have that this length is 2. This length is also 2. And by Pythagoras, these 2 lengths are square root of 5. Now, we wish to find the area of B, and B is this area here. And this kind of looks a bit daunting because it's really hard to relate these lengths to anything. But notice that this is 90. And if we drop an altitude from here, from M to this side length, this is also 90. And they share this angle here. So therefore, we have that this triangle is similar to this triangle. And this is really useful because this triangle, we can find this triangle's area or like properties pretty quickly. Because this is the midpoint, this is 1, and because this is the side length, this is 2. Now, this triangle is similar, but this triangle now has hypotenuse 2. So this side length is equal to this side length times the ratio of these two triangle side lengths, or just 2, in this case, this is equal to this times square root of 5 over 2. Since this is 1, this is actually just, oh wait, this is not square root of 5 over 2. This is 2 over square root of 5. Whoops, never mind what I said. 2 over square root of 5. And this becomes 4 over square root of 5. 4 over square root of 5. Because this is twice this, since this is twice this. And now we have this length, and we can use the area formula. 4 square root of 5 times 2 square root of 5, the two bases of this triangle, B, divide by 2. And this turns out to be 8 over 5. And then finally, we wish to find 3 times the area of B, which is just 24 over 5, and this is indeed option choice A. And we're done. Thanks for watching.